In our paper, A-Okvqa, we made a new visual question answering dataset whose questions have a unique emphasis on common sense, visual, knowledge base, and physical knowledge, and find that existing vision language models underperform on these skills. The authors are members of the prior team at the Allen Institute for AI in collaboration with Carnegie Mellon University. Visual question answering is a prominent vision language task in which models are expected to answer questions related to images. Originally, this task was conceived as a visual Turing test for AI systems, expecting a machine to perceive visual cues and understand language, while also reasoning about these inputs and leveraging knowledge about the world. But if we look at examples from the first VQA dataset from 2015, we instead see that these examples are focused on skills related to recognition tasks, like classification, attribute detection, and counting. We argue that state-of-the-art computer vision models have a close mastery of recognition-related skills, resulting in saturated performance on such VQA datasets. More recent VQA datasets have increased emphasis on knowledge and reasoning requiring questions. However, these datasets tend to be drawn from a closed source of knowledge, like knowledge graphs, or are proposed as diagnostic datasets with synthetic data. A few exciting datasets have increased their emphasis on common sense reasoning, however, are centered around the domains of people rather than of a worldly domain, and are restricted to multiple choice or scene graph answer formats. Finally, while the Okkvqa dataset has attempted to ask questions requiring more open-ended world knowledge, we find that the questions do not require reasoning about the image itself, and that the knowledge can be primarily looked up. For these reasons, we propose our A-Okvqa, or Augmented Outside Knowledge VQA dataset. We wanted to emphasize the need for common sense and visual reasoning in our questions and images, while also requiring some world knowledge. Here, we have some examples from our data, where each image has a question, multiple choices, 10 direct answers, and a rationale for the correct answer. During test time, the model is just provided the question and image, as well as multiple choices in the multiple choice setting. In our other setting, the model should predict the answer directly. For example, in the image on the bottom, a model must determine that one person will dine at this table, because it must use common sense reasoning to infer that the place settings, such as the amount of water, food, and utensils, are intended for one person. Our images originate from Microsoft Cocoa, and annotations are collected by Amazon Mechanical Turk workers. Our dataset is slightly larger than most previous knowledge-based VQA datasets, with the exception of the VCR dataset. Our dataset has a long-tail distribution of answer occurrences. From a survey, we find that the most common skills required to answer our questions are visual and common sense reasoning. Please pause this video here to take a look at some examples of knowledge types that are commonly found in our dataset. Please refer to our paper for a comprehensive evaluation of large-scale pre-trained or foundation models. We test these models, such as CLIP and GPT-3, in a number of settings, where the model is provided just the question, just the image, or both the question and image. We find that most of these models underperform on our task, especially in the direct answer setting, where the model is not provided multiple choices. Of these models, the highest performing is ClipCap, which maps clip image features as prompt tokens for GPT-2. This model is adapted from an image captioning setup. It is instead provided questions and expected to generate answers. We also evaluate high-performing, open-source vision language models that are pre-trained on some form of VQA, then fine-tuned on A-Okvqa. These models outperform the foundation models, but still leave room for improvement. We also train models that generate rationales for questions and images, which can be provided to GPT-3 for producing the final answer. We find that generating or using ground truth rationales leads to an improvement in model accuracies, so this is a promising approach for further exploration. We include a full analysis of our model performances in our paper. We hope you share our excitement of further development of VQA datasets on larger scales and messier distributions of images, and models that are interpretable, explainable, and have a higher capacity for combining knowledge and reasoning. Thank you.